So we're going to be covering LeetCode problem number 373, which is find k pairs with smallest sums, which is a medium level mark problem. So you're given two integer arrays nums1 and nums2 sorted in non-decreasing order and an integer k. You need to define a pair u comma v which consists of one element from the first array and one element from the second array, and we need to return the k pairs u1 v1 u2 v2 with the smallest sums, right? So for example, we have nums1 as 1 7 11 and nums2 as 2 4 6. Then the basically we need to create all types of pairs, that is 1 2, basically 1 2, then 1 4, then 1 6, 1 2 1 4 1 6, then 7 2 7 4 7 6, 7 2 7 4 7 6, then we 11 2 11 4 11 6, and similarly, and then we have to sort their sums. So you see the sum of 7 and 2 would be 9, then 7 and 4 is 13, sorry 11, and 11 and 2 is 13, and then we have 13 again, 7 and 6, 11 4 would be 15, and 11 6 would be 17. So these are all sorted in ascending order, and we need to return the basically the smallest sums. So these are the smallest sums, that is 3 5 and 7, right? So you see the smallest sums, and similarly here 1 1 2 1 2 3. So basically you see 1 1 can be a pair, then 1 1 here also is a pair, then we have 1 2 which is a pair, right? But we need only 2, so we are going to be choosing the two elements, that is 1 1, which have both a sum equal to 2. So once we have decided that, we're going to move on to the solution. So a max heap would be used here. So let me talk about the intuition part. So basically this is a classic top k smallest sums problem. Brute force would be to generate all m cross n pairs and sort based on sum, right? And it is too slow if nums1 and nums2 are large. Better idea would be to use a maximum heap of size k to maintain only the top k smallest sum pairs, right? Push the new pairs into the heap only if they are better, that is only if they have a smaller sum than the current largest sum in the heap, right? And we use a maximum heap because we are going to maintain top k smallest sum pairs, right? Why? Now you might think we have a maximum heap if we are considering the smallest or the minimum sum pairs. So basically we have to choose pairs in such a way. Let us say we are pushing the sum and the index value. So let us say the index basically index values would be from index nums1, so that would be index 1 and index 2. So let me talk about it again. Let us say we are pushing and we have sum index 1, that is from nums1 vector, and index 2 from the nums2 vector, and we are going to be storing it in this format in the priority queue. Okay, that is the max. Now we have to decide which heap, that is a max heap or a minimum heap. Let us say k is equal to 2, and let us say we have a sum equal to we are getting sums as 3 5 7 and 10. Okay, these are the elements. Let me not take the indices just to simplify this solution. So we first push in 3, and let us say the indices are anything else. It could be anything, you know, indices are not of our priority right now. And then we push 5 in, and the indices again not of priority, so I'm not mentioning it. Then since k is equal to 2, we have to check here. Now if we are pushing 7, right? So a max heap, what a max heap technically does is it keeps the maximum elements at the top, right? So that is why 5 is also at the top and 7 is at the top. And we are maintaining a max heap because we only need top basically the k elements that have the minimum sum, right? The top k smallest sum pairs. So we see if the size of the priority queue, if pq.size exceeds k, so in that case we would pop the topmost element. And in order for us to keep track of the topmost element, we need to have the maximum element on top. Why? Because we have to maintain only the minimum sum pairs, right? So the maximum element can be popped out. In case we took a minimum heap instead of maximum heap, then we had the sum 3 above and then 5, and then some would come below. So we couldn't we won't be able to actually access 7. So that is why instead of a minimum heap, we chose a maximum heap to store the largest or the maximum sum above, so that in case the size of the priority queue exceeds k, we can remove that maximum sum element from above. So that is why we are choosing a maximum heap. So that is the explanation. Why maximum heap? So we can eject the worst pair or the highest sum when a better one comes in, right? So that is the answer. And I basically explained to you in depth why we are choosing the maximum heap instead of over a minimum heap. Now approach is to use a maximum heap of size k, iterate over each pair nums1 of I and nums2 of j, maintain the current pair's sum, push it into the heap if the heap has less than k elements, or the current sum is smaller than the largest in the heap, that is of pq.top. So we push into the heap if the heap has less than k elements, or the current sum is smaller than the largest in the heap, pq.top. And optimization, since the arrays are sorted, once nums1 of I plus nums2 of j is greater than pq.top, we can break in a loop. There is no need to continue for bigger values of j because we know that the sum has already exceeded that value. So all the other values that are after index equal to j, that would be obviously bigger because bigger values we don't actually need. So we are choosing only the minimum values, right? So that is the optimization. And the time complexity of the worst case would be of mn log k, because we may insert up to m times n pairs into the heap of size k. And we optimize early so as to bring our time complexity down to not get a TLE. And space complexity obviously is of k because it takes a heap and stores at most k elements. Now let us get to the most important part, which is the code part. So here I'm basically I've done type def pair int comma pair int int. So basically in this I'll be storing my sum in the priority queue. I'll be storing the sum, and the coordinates I comma j. These are not the coordinates, these are the index values. I is basically from nums1 and j is for nums2. That is the index value of nums2, and this is the sum of nums1 of I and nums2 of j, right? Sum is that value. Okay, so m is nums1 dot size and n is nums1 dot size, nums2 dot size. So then we maintain a priority queue, which is going to be a max heap, and I've taken the pair int comma int to store the top k smallest sum pairs in this format, sum and the I and j, which are the index values of nums1 and nums2 respectively. So it stores top k smallest sum pairs. I explained to you the idea behind max heap here. Now, if the heap size exceeds k, we have to remove the one with the largest sum, right? That is why we're maintaining max heap. So we are traversing over each index, each element in the in both the vectors, that is in nums1 and nums2. For I in range, basically for I from 0 to nums1 dot size, and for j to nums2 dot size. For all the pairs we are considering, we calculate the sum for each nums1 I plus nums2 of j. And in case the pq dot size is less than k, that is in case we have not reached the number of elements that we need, that is the minimum number of pairs, then we can push the sum and ij values. Otherwise, if pq dot tops first is greater than sum, that is now we have reached basically the largest sum. We get a sum, we get a bad pair, that is one with the largest sum among all the ones currently present in the priority queue. So in that case, we basically have to pop out the largest sum value, right? We pop out that element, so pq dot pop, and push the new one, that is the sum ij, that is the value of sum, which is the minimum, which is lesser than the pq top dot first, right? So the minimum value is pushed into the priority queue along with the I and j, that is the indices. And otherwise, since the arrays are sorted, the future j will only increase the sum. So this case is when we are considering the j, since the arrays are sorted, right? So the values will keep on increasing, right? And the sum, because these values in nums2 or nums1 would be increasing, the sum would also, corresponding sum would also be increasing. So for optimization, we have put a break condition here. That is, after this, obviously it would be a break condition, because we don't need to go towards a larger sum, because we are required to get a minimum sum. And finally, we basically take answer as the vector of int type to get all the pairs from heap and store it in answer, right? So in answer, we are going to be pushing the indices, the values, that is nums1 of I and nums2 of j. So we extract that from the priority queue and pop that element from the priority queue. Till the time priority queue is not empty, we do this. And I and j we extract, that are the indices, and the corresponding values are nums1 of I and nums2 of j, and we push it into the answer and return it. So that would basically return our k pairs with the smallest sums, like this and in this format. So that's it about this video. Thank you guys for watching.